Hi and welcome to Data Garden. Thanks for checking out my channel. I hope you're doing very well. Today we're back with the XGBoost in R series, and we want to start our course with a very simple classification problem. So let's get right into it and start a new R script. File, new R script. And in the first step we have to of course install the package XGBoost if we haven't already. So we use the install.packages command, and we simply type in quotation mark XGBoost like that, all small letters, and we press run. In my case the package is already loaded, so I have to restart RStudio before I install, and loads the package, and there it goes already very quickly. Now, two quick tips about this. First of all, you might have it, for example, if you're using a laptop from your firm that was sponsored for you, that there are some security applications on it that will prevent you from compiling packages. In this case, what you can do is, of course, you can use the binary package, which you can always install, and you can do that by going into the command here, and after the second quotation mark you can type comma type equals binary. And yeah, oftentimes I also prefer to use this installation type, because the binary installation might be a more longer tested, more stable version of the same package. And so I think there are some benefits to that, let's say. Also keep in mind that if you're using Windows operating system, then you will need to have RTools installed in order to properly use XGBoost, which if you use RStudio like myself, then it will already be included with your installation. But if you use, let's say, R in the command line, then it will not be included with the base installation. Okay, but if you have RStudio installed, then we can of course use the library command to load the package. And we can also load our data set with the command data. And we want to use the iris data set, which, if you've been following, for example, my R beginner series, then you're already familiar with it. Maybe we can quickly display the first couple of lines of the iris data set with the head command, and we will see that it has 4 predictor variables and the species, which is what we're going to predict here. Now, before we go into the splitting of training and test data, there's one little bit of a specialty maybe with at least the native implementation of XGBoost, which we're using here from the XGBoost package, which is that it works better if you give the program a number for the class definition, which means, let's quickly do the table command of iris$species here. So as you can see, there are 50 observations of setosa, 50 of versicolor, and 50 of virginica. And in order to feed this algorithm, it's better if we encode it to 50 of type 0, 50 of type 1, and 50 of type 2, for example, which is the first thing that we want to do before we continue with the prediction process. So let's create a new variable in the data set. We're going to call it iris let's say label, and we're first going to define it or assign it an A, so no value. And now we're going to assign it a 0 if it's setosa, a 1 if it's versicolor, and a 2 if it's virginica. So we do that by typing iris$label, and then in the square brackets we select the criterion iris dollar species equal, and then in quotation marks I will copy paste it from down below, setosa, and if that condition is met, that iris $species equals setosa, then we will assign to the iris label the value of 0. Press run, and now we will do the same step again with the two other class labels. So to the name versicolor we assign the label 2, and to Virginica we assign the label 3. So I will quickly have a look at the data set now. Yes, we can see that indeed all of the observations with the species setosa have the label 0. Versicolor has 2. And oops, I'm just noticing that I did this wrong here. Should be of course 1 and 2, so 0, 1 and 2, and not 2 and 3. So we run these two again very quickly, and there we go, 0, 1 and 2. In the next step we have to of course split the whole data set of 150 observations into several, or 2 data sets to be precise, one on which we train the model and one that we use for backtesting to show that how our model actually performs. So we create a new data set that we call training, and we assign that with a selection of the iris data set, of course. So we type iris, and then in square brackets we type sample. That's the command that we want to use, and what we want to sample is from the row names of iris. So command goes like this in the square brackets: first sample and first opening bracket, row names, second opening bracket, iris, and then 2 closing brackets. And after that we type a comma, and then we select how many observations we want to have. Sorry, that has to be after the first closing bracket, comma 100, and then the second closing bracket, and then another comma, and then we go to the column selection, and in this case we want to have all of the columns. So we press run, and indeed we see we have a set of 100 observations, and we can see that, for example, the observation 82, 52, 67, and so on are in here. And the standard parameter of the sample command is that it, let's say, doesn't resample the same observation, so each observation can only be taken in once. Then, of course, we also have to define the testing data set, and that will be also from iris. And in the square bracket we will select all of the row names of iris. Sorry, we have to put a exclamation mark in the front to show that we don't want the row names of iris that are percent in percent the row names of training, and then in the end, before the closing square bracket, again a comma, so that we select all of the columns. And as you can see, we have data frame testing of 50 observations, which makes perfect sense since the whole data set iris has 150, training has 100, and testing has 50. Now, there's one specialty about XGBoost, and that is that unfortunately it cannot handle a regular data frame as a input variable, at least not in the native implementation that we're doing here. So we have to define two more objects which will have the class of the XGB dense matrix. So we can, for example, call them training underscore input, and we will define that as command XGB dot dmatrix, like this, with capital D and capital M. And then we have to pass at least two types of information into this command, which is the data and the label. In this case, the data equals training, and of that the columns 1 to 4 and comma 1 to 4, because we want to have all rows, and then the columns 1 to 4. And it's a bit of a trick here as well, because the dense matrix cannot be created from a data frame but only from a matrix. So we have to use the command as.matrix inside this command, and then have two closing brackets here. But after the first closing bracket, we have to still define with a comma label equals training $label. So we do have a bit of a complicated command here. So let's go over it one more time. It starts with the command xgb.dmatrix, which stands for dense matrix. Then after the opening bracket, we first define data as s.matrix, and then the second opening bracket training, and in the square bracket we select all rows and only the columns 1 to 4, then the first closing bracket, and then comma, and as the second part we define the label equals training $label, and then the second closing bracket. So let's hope we have done everything right and press run, and yeah, it looks good. And then we will do the same with the testing input, because that will, for the prediction, we will also need a dense matrix. So we do the same structure, xgb.dmatrix. Data will be in this case as.matrix testing, and in the square bracket, comma 1 to 4. And after the first closing bracket, we will define label equals testing $label. And we press run again, and also that works. So yeah, that's good, and we can get right into the creation of the model. So we will assign a name to it, for example, XGB underscore model, and we will assign to that model of the class xgb.train. That's the command that we need. And you can see we can enter a whole bunch of things into this command, but we will not need the vast majority of them just yet. The first thing that we have to define is, of course, the data. So type data equals, and that will be input training input. Then we have to define type comma, and in the next line we have to at least define how many rounds of training we want to do. Remember, in the first video, in the introduction video, I tried to explain to you that XGBoost builds model after model and always fits it onto the residuals of the previous model. And we define how many models will be built by typing n rounds equals, and let's say we want to start with 5 models for a start. And finally, we have to define how many classes there are. So we type comma and then num underscore class equals 3. And that should be it. Let's try to run this model. And it goes without errors, and it goes very quickly, as you can see. And so we can already go on to the prediction. And we do that by typing testing $predicted. Let's say, let's create a new variable called predicted. And we can just use the standard, the built-in predict command from R. So predict, and the object, the model that we want to use is of course the XGB model that we have created. And the new data will be testing input. So we press run, and we can have a look at our testing data set. And we can already see that our predictions are apparently quite decent, where most often we have, for example, here the label is 0 and the predicted value is also 0. And here the label is 1 and the predicted is also 1. In this case, it looks like it's almost completely correct. But to make our life a little bit better and easier, let's actually retranslate these predictions into the original species names. So we do that the same way as we did here, except the other way around. So we type testing $predicted, and then in the square brackets we select testing $predicted equal 0, and then after the square bracket we assign to that the name setosa. Press run, and we do the same 2 more times, where we, if the label is the predicted one, label is 1, then it will be versicolor, and if the predicted label is oh sorry, I forgot the closing quotation marks there, and if it's 2, then it will be Virginica. So press run 2 times again, and let's have a look at the testing data set again. So you can see the actual is setosa, and the predicted is setosa, and so on. And the same is true for almost all of the observations. We just see here there are a few errors where the actual value is Virginica and we have predicted versicolor. Now maybe let's create another column here where we quickly see how many predictions we have gotten right and how many wrong. So let's type testing let's call it check, and we define that as testing $species equals testing $predicted. Press run, and let's show the summary of that. Test summary of testing check, and we can see we got 46 predictions right and 4 predictions wrong. Now, as a first attempt, we can try to increase the number of rounds, for example to 50, and see if that helps. So we just change n rounds to 50 and then run all the commands starting from line 21 again. And that is unfortunately not the case. Now, in one of the future videos, we will be talking about parameter optimization and how we can get the most out of our XGBoost algorithm. And maybe with that we can still get a slightly better prediction accuracy, where we can maybe get all predictions correct, or maybe at least all but 1 or all but 2. Also keep in mind that because we did random sampling here to define our training and testing data set, maybe for you the result will be slightly different because you have sampled your rows for training and testing differently. So I hope that you could follow this tutorial well until this point, and that you have also come out with your result. We can have another look at the data set here. We can also order, so there's in fact one observation that is actually versicolor that we classified as Virginica, and 3 that are Virginica and we classified them as versicolor. Yeah, like I said, I hope that you could follow this tutorial. If you did, then why not post in the comments what results you got, what was your prediction accuracy. If you like this tutorial, then make sure to subscribe to the channel, because I have more videos coming up on the XGBoost algorithm, where we go into regression problems, where we go into the implementation in Caret, which makes a few things a bit easier and better, and where we also finally will go into the parameter optimization and see how to get the very most out of this algorithm. All of this will be coming up very soon, so I hope I can see you there. Until then, have a great time and bye bye. Thanks for watching.